Okay, so here we are with question 2 on the worksheet, and it says that a car at 0 seconds has a speed of 30 meters per second, and at 6 seconds has a speed of 14 meters per second. Want to find the average acceleration during the interval. So we're going to start looking at our velocity graph. It says the car starts off at 30 meters per second at the beginning, so we make a little mark for our 30, and we know we're going to go down to 14 meters per second over the course of 6 seconds, like that. And so then we can just draw a line from the beginning down to the end. And the slope of this line should be the acceleration, because the slope on the velocity graph is the acceleration of the object. So we can find that by simply finding the change in velocity over the change in time. So we do the change in velocity over the change in time. That's the change in y over the change in x. So we're going to say we go negative 14 meters per second in 6 seconds. So that's going to be 7/3 meters per second squared, which would be equal to 2.33 negative through there meters per second squared. So that's simple enough. That's all the question asks for. But let's also, the instructions of the worksheet also ask us to make a position versus time graph as accurate as we can, which means we should attempt to find the displacement. So in the position graph, we know, we'll just say we're going to start off at 0 meters at the beginning. We're going to travel for 6 seconds, and we want to maybe figure out how far this car is going to travel over that 6-second interval. In the last unit, when we just had constant velocity, we found the displacement by looking at the area under the velocity graph. We're going to do the same thing now, even though we're accelerating. So over here, my area under the velocity graph would be the whole area between my graph and the x-axis. So it would look something like this. That shape is a trapezoid, and if you remember the equation for finding the area of a trapezoid, you could use that. But if you don't remember that equation, another way to go about doing it is not to think of it as one big trapezoid, rather to think of it as a triangle and a rectangle separately. And then you want to find those two areas. So the triangle's area, the height would be the distance that would be between the 30 and the 14, so it's a height of 16 meters per second, and the base would be 6. So the area of a triangle is 1/2 times base times height, so 1/2 times 16 meters per second times 6 seconds. So that's going to be 3 times 16, which would be 48 meters. Then the bottom, the rectangle on bottom, so the 48 goes there. The bottom would be the height of 14 meters per second times the base of 6 seconds, and that would be 84 meters. So that's the area of the rectangle. If I put those two together, my 84 meters plus 48 meters, ultimately I get a total area of 132 meters. So now on my position graph, I know this top part is 132 meters. This object starts with a very fast positive velocity, has a less fast positive velocity at the end, so my slope should be decreasing on the position versus time graph, not getting quite to 0 and staying positive. So it would look something like that, a decreasing positive slope throughout, but doesn't ever get down to being quite flat.